Hello class, welcome to the next module of the chapter surface tension, and in this module also we are going to have a look at MCQs on work done. Now class, in the previous module also we have seen 4 MCQs on work done, and in this module we are going to see 3 more MCQs. So let's have a look at the 5th MCQ on work done. And the question says that the work done in blowing a soap bubble of radius capital R is capital W. The work done in making a bubble of radius 2 times the original radius, that is 2R, from the same soap solution will be 2 times W, 4 times W, W upon 4 or W upon 2. Now, the solution is, formula for calculating work done as we know is dW is equal to T into dA, where dW is the work done, T is the surface tension, and dA is the change in area. So I say that dW is equal to T into dA. Now class, initially the soap bubble was of radius capital R. Now we know that dW is equal to 2 into dA, 2 into T into dA. Now you must be wondering, why did I write that 2 there? I wrote 2 there because when you talk about a bubble, bubble has 2 free surfaces. Okay, one outside exposed to air and one inside exposed to air. So when you talk about bubble, bubble has 2 free surfaces. Now we know that dW is equal to 2 into T into dA. Now when you talk about the soap bubble of radius capital R, it becomes dW is equal to 2 into T. Now class, when you write area becomes 4 pi R square, and since the radius is capital R, my dW becomes 2 into T into 4 pi capital R square. That is nothing but dW is equal to 8 times T pi capital R square. Let me call it as equation number 1. Now class, we know that this soap bubble has been now converted into a soap bubble of radius 2R. So this time, if the radius is 2R, I say that dW dash will be equal to 2 into T into again 4 pi R square, but this time my radius would be 2R. So this will become 2 into T into 4 pi into 2R square, which is nothing but 4R square. So if you solve it further, you get 32 times T pi capital R square. This becomes dW dash. Now class, 32 can be written as 4 times 8T pi R square. But class, 8T pi R square is nothing but my original work done. If you see here, that is nothing but my value of dW. So if you substitute, this becomes dW dash is equal to 4 times the initial work done. Now class, if you look at the question, the initial work done was W. So I say that dW dash is equal to 4W, which is nothing but your option B. Now, let's go for the 6th MCQ, and it says that if the surface tension of soap solution is 3 into 10 raised to minus 2 newtons per meter, then the work done in forming a soap bubble of 20 centimeter by 5 centimeter will be, and the 4 options are given to us as shown. Now, let's move to the solution class. We know that dW, that is nothing but work done, is equal to T into dA, where dA is change in area. Now, when we talk about a frame or a film inside a frame or a soap bubble, we know that we always have 2 free surfaces. So we always multiply that by 2. So we have dW is equal to 2 into T into dA. And the reason why did I multiply the equation by 2 is frame has 2 surface area. Now class, if you substitute the values, it will become 2, I can write it as it is. T is the tension, which is nothing but 3 into 10 power minus 2, and dA is the change in area. Now class, we know that change in area is as given in the question, it is 20 centimeter by 5 centimeter, which is nothing but 20 into 5, and to convert centimeter into meter, I write 10 raised to minus 2. But since I have 2 quantities in centimeter, I write 10 raised to minus 4. So if you solve this further, you get dW is equal to 6 into 10 raised to minus 4 joules, and that is nothing but your option C. Now, let's move to the final MCQ for the module and for the type of work done also, and that is 7th MCQ, and it says that the work done in increasing the size of a soap film from 10 centimeter by 6 centimeter to 10 centimeter by 11 centimeter is 3 into 10 raised to minus 4 joules. What is the surface tension of the soap film? And the 4 options are given to you as it is. Now class, you have a film whose original area is given to you as 10 centimeter by 6 centimeter. then you stretch the fill and the new surface area becomes 10 centimeter by 11 centimeter. And when you stretch, work has to be done, and that work done is given to you as 3 into 10 raised to minus 4 joules. You need to calculate what is the surface tension of the solution. Now, class, we know that dW is equal to d upon dA. So, I can write down surface tension is equal to dW upon dA. Now, class, work done is given to us as 3 into 10 raised to minus 4 upon dA. dA is nothing but change in area. Now, class, original area was 10 by 6 and final area is what? 10 into 11. So, I say that change in area is final area minus initial area. Final area is 10 into 11. Minus initial area is 10 into 6 into 10 raised to minus 7. Now you must be wondering that why did I write 10 raised to minus 7? Because I need to convert all the quantities from centimeter to meter into 2. Now you must be wondering that why did I multiply this by 2? Because when we are talking about a frame, I say that frame has two free surfaces. One on the upper side, one on the lower side. So I need to multiply this by 2. So I get 3 into 10 raised to minus 4 upon 2 into 110 minus 60 into 10 raised to minus 4. So, I end up getting final answer of surface tension as 3 into 10 raised to minus 2 newtons per meter. That is nothing but your option D. I hope you have understood the model, class. See you in the next model. Thank you.